Hello, Abdullah here. Welcome to the third video on the Kaggle CORD-19 competition. If you haven't checked the first two, I think it would be nice to have a look at them because I give a gentle introduction to the competition in general and the dataset from high level. Today I'd like to go a little bit into details and check the dataset using Python. So without further ado, let's hop in. So here is the Kaggle notebook. On the right here you find the dataset with different files, including directories containing the research papers. And on the left, the Kaggle notebook where I can have some text, like the ones here where I give some examples of the submissions that has been made, if you want to have a look at them. And then the code where I can execute a bunch of codes using Shift-Enter. And here is the actual traversal for the research paper documents. So here I go recursively, starting from the root directory and getting only the .json files and printing number of JSON files. So this is around 71,000. The focus of this video is to inspect the metadata. So in the metadata there is one entry for each research paper giving some information about it, like the title, the authors, its ID, the source of the paper, etc. and the URL to check it if you want to. So here I'm reading the file simply using pandas, and I'm using the head function to show the first 5 entries. So here it can give you a good idea about the content of this metadata CSV file. So there are two interesting functions in the pandas library. So the info and describe. So it summarizes somehow the data of the CSV file. So it tells you there are around 60,000 entries. And for the CORD-19 colon, there are the same number of entries that are non-null. And then whenever you find that, for example, in the SHA, so this is the hashing of the PDF, you find 45,000. So the difference actually is the cases where there were null values. The describe function summarizes the statistics, let's say, for each colon. Because data are mostly in string format, not numerical, so they give you the count, the number of unique values, and the mostly repeated value, so you can think of it like the mod. So this ID has been repeated 3 times, which raises little red flags, asking why the CORD ID, which was set to be specific and unique for each research paper, repeated in the metadata. In other columns you will also find the repetitions, and it can give you some good insights. So here in this class called paper meta, I try to inspect these duplicates, where I have a method called remove duplicates, where I send it the colon name, and then it will figure out the cases where for one value in this colon there were actual repetitions of the paper, and then we can go through this. In this part of the code, I simply create an instance of the paper meta class, and then I remove duplicates. In one time I remove it based on the CORD-19 colon, because this was set by Kaggle that it should be specific for each research paper. It should be unique for each research paper. And I show the URL of the duplicates so that I can inspect them manually if need be. And then also the cases where the title is repeated, because I find this interesting. What are the cases where 2 papers have the same exact title? So if I run this, when the CORD-19 is done, I print here the number of duplicates and the value that was duplicated, and the URL for each of the duplicates. And this is interesting because we might want to inspect them manually, let's say. Now, moving on to the title duplicates, it shows the same kind of outcome, so the number of duplicates. But here it's a little bit more interesting because, like, for example, there are 15 duplicates for papers all named Public Health Roundup, right? If you go a little bit down, you will find also more duplicates for cases like correction, etc. So I summarize the output here in this textual format. So with UID there is a total of 36 duplicates, and then if I take 2 examples just to see if they are actual duplicates or not, so having the same ID, and you will find here that, so this is a 19-page document written by Frederick, and then in the other URL it's also a 19-page document written by Frederick. So with some inspection, you can be a little bit confident that if the UID is repeated, then I can just take one of the papers and exclude the others. However, there were much more duplicates using title, so around 1.2k title, and in some cases they were actually the same exact papers. So if I open those two duplicates here that were entitled with this title, then I open the links, I can verify that this is okay, 7-page, and then also written by Hannah, and then here also you can quickly find out. Other cases showed that the duplicates are actually an extension of one another, so same paper, same authors, but one is longer than the other. Other cases, which is the more interesting cases, were for general titles like news in brief or research highlights. The papers were actually totally unrelated, and they were not proper research papers, but rather maybe some articles. And this is interesting because it can be a door to work on outlier removal, which is an essential step for machine learning model building. Other cases where actually the titles were not English, so for these titles that were panorama or other German terms, the articles were in German, some were in French, some were in Spanish, and some were in Chinese. One interesting case where actually the articles were about cars and had nothing to do with the coronavirus. With this primary data inspection, we were able to find or highlight these interesting outlier documents, let's say, and by inspecting the content of each research document, we might be able to do a better job at finding outliers. This is going to be the focus of my next video, where I will introduce paper class, where I inspect the content of each of the research documents, hoping we can make some interesting conclusions out of them. So until then, thank you for your time and see you.